Now, we have been talking about ARP poisoning, but what about DNS poisoning? In DNS poisoning, we just simply redirect people when they're trying to do a DNS lookup. We send them to the wrong IP address. So let's talk about that. You should already know how DNS works and what it is. What we want to do is make a DNS server think that it has received authentic information. We want to substitute a real IP address with our fake address at the DNS level, either in a DNS server cache or in a client DNS cache. So we replace IP addresses with the attacker IP address, and we generate false DNS server entries that have the same name as the target server. So different ways of DNS poisoning. We could do it on the internet, do it on intranet, we could do it on a proxy server. We could also just poison the cache of a DNS server. We could also, quite honestly, poison the cache of a DNS resolver, a client, as well as its host file. So DNS cache poisoning, we are entering phony DNS records in the client's resolver cache or in a DNS server resolver cache. Like you might have an ISP here, and they just have a lookup DNS server that goes out on the internet and does all these lookups and keeps a copy. You could poison that. You could have a server for a company that has actual records for the company. It's what we call authoritative. You could put in bogus records there. It's easier to insert phony records into a cache. Or you've got little client machines that ask a DNS server, but they'll check their own cache first. So a little bit more effort, you could poison their cache so they don't even ask DNS. They think they already know the answer. The answer is just wrong. So most DNS servers actually query other DNS servers to resolve host names. If you can insert one false record somewhere kind of up the chain, it'll propagate to many DNS servers and clients. One way to deal with this is to use a bolt-on technology called DNSSEC, DNS security, that basically accompanies records with digital signatures. Unfortunately, it is not widespread. Every DNS server and client both have to use it, otherwise they'll ignore it and they'll use the phony addresses anyway. So we can see in our little picture here that I've got a local DNS server. I'm putting in phony records so that when a client tries to do a lookup, they, instead of going to the proper address, they go to the pirate address. There are other name resolution exploits that are not just DNS. DNS is one way of doing name resolution, although it's the most common. Once upon a time, we had something called NetBIOS name lookups. Microsoft had something for their internal networks called a WINS server, Windows Internet Naming Service. And they also had little static files called LM host files. If these are still used in your network, highly unlikely, but you never know, you could tamper with these. Now Microsoft has something new. It's a multicast called Link Local Multicast Name Resolution, LLMNR. It replaced NetBIOS. It uses multicasting instead of broadcasting. It's what Microsoft machines now use. In both IPv4 and IPv6, there are exploits to poison those as well. Basically, to pretend that you're responding with an IP address, but it's the wrong IP address. So the Windows name resolution process, very first thing is if I need to look up like an IP address, I know a name, I don't know the address. A Windows machine will first check to see if it itself is the destination. Then it will check to see if it has ever looked this up in its resolver cache. And then it'll check to see if it is in its host file, which is basically like an old phone book in Windows System 32 drivers etc. Then it'll go query a DNS server. And if that fails, then it'll send out an LLMNR multicast on both IPv4 and IPv6, UDP port 5355. And then if absolute worst comes to worst, it will try the old NetBIOS broadcast also to UDP port 137. So obviously we want to corrupt the DNS resolver cache first. We want to corrupt its lookup cache first. And then if that doesn't work, you can have fun changing the host file. That'll mess things up. Or you mess with the DNS server. Or if you know that's not going to work, you can have a tool like Responder, which is a Linux tool, make phony responses when this machine is multicasting saying, hey, who out there is da-da-da-da? And you just send back these phony responses. Probably no one is doing the NetBIOS broadcasts anymore, but you never know. So how do we defend against all this spoofing? Well, try to make sure that you're in control of the local server. Keep an eye on it. Make sure you have intrusion detection set up properly. No DNS recursion, meaning it's not going to go querying other DNS servers. Of course, sometimes you can't help that. Make sure that DNS requests are blocked from external servers. Implement that digital signature thing, DNSSEC. Make sure that you've turned on non-existent domain rate limiting. This is a little thing you can set in DNS. Configure the firewall to ensure restriction of external DNS lookups. In other words, don't let people go out on the internet to look up something that your local server can tell them. Of course, though, if we can compromise the local server, that's not good either. Configure the DNS resolver to use random source ports for outgoing queries and make sure the internal machines are secure. There are tools that will watch for cache pollution on DNS servers. So that is what we need to know about DNS attacks.